Now let's try example 5, question number 2. A cylindrical tank has a base with radius r equals 2 meter. Tank is filled with water at the rate of 2 meter cubed per minute. Find the rate of change of the water level in the tank. So in this case, we're going to need to find the rate of change of H with respect to T. So find dH dt when r is equal to 2 meter. And it is given that dV dt is equal to 2 meter cubed per minute. So we know that the volume of a cylinder is V equals pi r squared h, and the surface area of a cylinder is equal to 2 pi r squared plus 2 pi r h. So in this case, we are going to use V, since we are provided with dV dt. So now let's take V as our subject. So we have V equals pi r squared h. So if we differentiate V with respect to t, so we get dV dt. And on the right hand side, we differentiate h with respect to t because we want to find dH dt. So we get pi r squared times dH dt. And then rearrange that, we get dH dt equals 1 over pi r squared times dV dt. So when r is equal to 2 meter, dH dt is equal to 1 over pi times 2 squared times dV dt, which is also 2. So finally we get 1 over 2 pi meter per minute, or we can also say that 0.159 meter per minute. So that is dH dt. That means for every minute, the level of H increases by 0.159 meter. Now let's try example 5, question number 3. A 10-meter ladder rests against a vertical wall. If the bottom of the ladder is sliding away from the base of the wall at the rate of 3 over 4 meter per second, how fast is the top of the ladder moving down the wall when the bottom of the ladder is 6 meter from the base? So in this case, we want to find the rate of change of y with respect to time as x moves away from the wall. So that means we are looking for dy dt when x is equal to 6, and it is given that dx dt is equal to 3 over 4 meter per second. So from the diagram, since it is a right angle triangle, they are all related as in Pythagoras' theorem. So we have x squared plus y squared equals 10 squared. So when x is equal to 6, we have 6 squared is 36 plus y squared plus 100. So y squared is equal to 64. So y is equal to 8. In this case, y can only be positive because it's distance. So we don't take the negative root of 64. Now from the Pythagoras theorem, we can differentiate x and y with respect to t. So first, let's differentiate x with respect to t. We get 2x times dx dt. And then differentiate y with respect to t, we get 2y dy dt, and then differentiate 100, we get 0 because it's a constant. And now we want to look for dy dt, so we rearrange everything so that we get to find dy dt. And then next step is 2y dy dt is equal to negative 2x dx dt, and then move 2y to the other side, so we divide both sides with 2y. Dy dt is equal to negative x over y times dx dt. So we know that x is equal to 6 and y is equal to 8, and dx dt is equal to 3 over 4 meter per second. So dy dt is equal to negative 6 over 8 times 3 over 4, which is equal to negative 9 over 16 meter per second. So in this case, we can see that the rate of change of y with respect to t is negative because y is decreasing as x is increasing. So that's why the rate of change is negative.